Welcome back to the Niagara Learning Channel. Richard sent me a YouTube message asking for optimized VT heating video, so we're going to do that at the moment. So I'm going to just carry on this station that I did on previous videos, but I'm just going to open up a new folder in my Logic. New folder, optimized heating VT. We'll go into that folder. Right, we'll drag across a optimized unit in energy. Drop that into there, and these are all in Fahrenheit. You can see the upper comfort limit there, 77, lower comfort 68, so they're in Fahrenheit. So we're going to keep it in Fahrenheit. We need to keep it in Fahrenheit, and we will put our Celsius and change it to Fahrenheit, our inputs. And then we've got the dynamic point parameter adjust. This adjusts these parameters here. That's naturally cooling, we're only doing heating, so it's going to adjust these here, but we'll set it up for cooling. Well, we'll set it up for heating, but which is the heat mode there. We can change it if we wanted to cool mode, or we can do heating and cooling, but we're just going to do heat mode here. No, I don't want to save anything, leave it as it is. I do want to expose them points though out, so upper limit and lower limit, so we can put the points in there. You can physically just set them in there if you wanted to, but it's nice to give adjustments from the client. And then we need a boolean, so let's go to our boolean, our schedulers, because we definitely need a scheduler installed. So we'll put that into there, and I don't know, let's say this is a office times, and we need to put in the times of when the office is occupied, not before. So you wouldn't go from 6 AM to start the heating, you do it from the time when you want it to be on. So let's say 8 o'clock. Well, we're not going to be working on a Sunday, so I'll delete that in a minute. 8 while 6, apply Monday to Friday, get rid of that one, delete. So we're working Monday, Tuesday, Wednesday, Thursday, Friday, 8 while 6, and maybe some of them come in early just for the afternoon time in the office, maybe, I don't know. We'll put that in there, and then we will link the out into the scheduler status there, the next time into there, and the next value into there. Now we've got an outside air temp, but we're not going to use the outside air, or this doesn't use the outside air, but what we'll do is let's just stick some numeric points in here at the moment. So let's do outside air, and we'll change it to Celsius. Okay, temperature, where are you? Are you there? Put you to Celsius. Okay, we'll leave for 1 decimal place. Save that, and we'll take out the in 10 in this time and the in 16, and just have the set, so we can just play with the values. Action set, and we'll set the outside air at say 14 degrees for the moment. Now we need to convert that into Fahrenheit for this block. A lot of people will just take that and put it in there. You don't want to, it's not going to work. You need to convert it to Fahrenheit. So let's go back to our kit control and conversions. Kit control, and numeric unit converter. Drop that into there. So that is under your conversions there. And rename OAT to F to Fahrenheit. Put that into there. I'll just make that a bit smaller, and then go into the unit converter and change the output to Fahrenheit. Say if you're doing all the calculations, like so. So that's 52, so that's my outside air temp. Let's also do the space, which is the space is the bit where you're going to be monitoring, that you want it to start for. So you may have various space temperatures, and you can take the average of them. If you wanted to, you could take the minimum. If you wanted to, you could take the maximum, but I would just take the average, and that needs to be space to Fahrenheit. And let's say our space temperature at the moment is, it's 18 degrees. So that's our space temperature going in there. These starts and stops, these are actually going to go eventually into a Boolean writable. Optimized heating. I hope if I spell it right. Optimize. I know it's Americans a Z. And let's expose some slots in here, because we'll be putting a lot of null values in. So we have that, have that, have that, have that. We're leaving 16 at the moment, but we could, yeah, just leave them as it is at the moment. So null value is not running. I think we will need an override, so which we'll put into in9. So I'm just trying to just tidy up that bit there. So we'll go for a Boolean writable, and we'll just call it override. We'll set that as a false at the moment. We'll take out the in10 and in16 because we're just playing on this sheet. Put the set in there. And then what we'll do, we'll hide, because when you go actions, you've got all these emergency actives. Let's just hide all them. So views, AX slot sheet, all them, highlight them all, config flags, and that's hide them all. Go back. So when you right click and go actions, you've only got the set. And we'll do the same for that one. Views, AX slot sheet, all them, actions, config flags, hide them, and we'll do the same for that. Views, AX slot sheet, let's hide all them, config flags, hide. So now if we right click that, we've just got the set command. So that's the office tabs, outside airspace. We want frost protection, and we don't need to do a conversion for that, but we also need the upper and lower limit controls, don't we? So let's duplicate that and duplicate it again. Rename upper limit, the maximum temperature. Rename upper. Rename lower limit. Rename lower. So we'll have our upper limit at say 23 23, 24. Let's do 23. And we'll have a lower limit at 20, 19. So that's our upper limit. They had 77, whatever 77 Fahrenheit is. And our lower, they had 68. And we're putting 66.2. That's going to be our outputs into here. So that's our stop output. Let me just show you the optimization. If you right click optimization, go views and guided help, and I'll bring it across. I've got it somewhere here when I can find it. No, not that one. There it is, guided help. Let's make it a little bit bigger. So that's your kit control optimized start and stop, and you can see when I scroll down to the so the lower comfort limit defines the heating mode target temperature. The upper defines the cooling mode target temperature, but we've just put both in. Default 77.25 and default 68.20, so we know what they are now. So 25 to 20 is the units that they are using. And I wanted to, this one here, the drift time per degree heating user defined, sets a drift value for calculating the drift in the heating mode. The component copies this value to the drift time degree heating property, and this one here, drift time per degree heating, this one, the component automatically adjusts this value if dynamic parameter adjust value is set to true, which it is. We've done that, we've set that to true. And then I presume the other messages here is your start time is there, and your stop time is there. So you've basically got all the information you need on the help guide for this. Let's move that back across to there, out of the way. So we need now to sort out the start time and stop time. So stop time is going to be priority. My override, which I haven't finished yet, I'm going to put that into in9. My stop time I will put into, for example, in13. My start time I will put into in12 for now. The reason I'm leaving in 16 is I'm going to do frost protection. Let's do that now. Duplicate. So we'll set a frost protection set point. And if it goes below, I don't know, let's say 16 degrees, we can go into frost protection mode. So I'm going to put a T-stat in there now. So a T-stat, bring that across, put just frost there, expand the points. I'll expand the action for this one because I'm going to also do another one. I'm thinking ahead at the moment, but I'm doing another one for the outside air. And we'll put that frost protection into there for the set point. The space into there. The difference we'll put as 1 degree, so that's 0.5 either side. We leave that as direct, and null on inactive. We're going to set that to true. Save. And is that right? I think direct 18. So that's going to be null on in control. Let's put that to false. I'm wanting that value to be a null. Let's set that actions in set to 14 degrees space temperature. That's false. I want it to be true. Reverse direction. That's right there. And then when I set that to 20 degrees, I want that to be false, but I'm going to want that to be null. So I was right at the beginning there, null. And then I want to put in a not gate. No, I don't. Let's leave that there exactly as it is. I want to use the not gate for when it's outside air above a certain temperature. So outside air high set point. So say if outside air goes to 23 degrees or 22 or whatever, let's just duplicate that. OAT high. So whatever it happens when outside air gets high, we are stopping completely. Put that in the wrong place. We will stop completely the heating. Control variable outside air, and we want to put that to a direct, opposite way round. We take that, put that into there, and we take that and put that right into, we'll put that into in 10 because we're going to use in 9, which I haven't finished that yet. Let's put an OR gate in there, but I'm going to put the OR gate to a null on inactive value. So when we put a false in there, it should be a null out. We actually don't need the B. We're not using it. All we're using that for is changing it for a null value. Put that to in now. So that's our override. Main enable. I don't know what to call it, but I'll leave it at that. So when we do an action set and we put that to true on a time on an override, we're going to put it straight on. So the heating's on regardless. It just misses out all this lot. Regardless of all this lot, that will put the heating on. Set that back to false. And then now it's going to be using the start time and the stop time in here. But if we get a frost scenario, so space temperature, set that to 14 degrees so it's really cold in there. I think that's outside there, 14 space 14. So that's our true there and a true there. We're putting our output on for heating. Let's put that back to emergency. So set that to, I don't know, 19 degrees space. I think that is it. That's our stop. So our stop has got to be before our start. So that's not right. Cut that. Cut that. Our start has got to be before our start. Put that in 11. And our start into there. So our final is stop, stops, regardless of what's on there. regardless of what's on there, which is my frost protection. I'm just wondering, we need to put our frost protection a bit closer. Let's delete them back out again. Let's take our frost protection out, and let's put our frost protection closer in. So our frost protection, that's our outside air. High temp, that's our frost. Let's just do this. Views, let's just number. So 10 is outside air I. OAT, high. That's our override. That's our frost protection. Okay. Right. And then we still got to do our start time and our stop time. In there, we're in heat mode. Lower comfort, how have we done that? So it's our stop time now. So our stop time's got to be before our start time. In the, because I don't know if you know about the you in 16s all the way through, but let me just go views and slot sheet. These are priorities. So this is an emergency override priority, and I think you will find if I do views, actions, emergency active, you see that one there. See that one, the at one? That's basically put that in there, that true, because I've just done an emergency override. This is reserved, 6 is reserved, 8 is reserved for normal override. Oh, let me show you that one. Let me take that off. Emergency auto, actions, active, permanent at the moment. That's now an 8 there now. So that is actually going into in 8 there, override. And then all these are what we can use for priorities. So the lower the value, the highest the priority. The higher the value, the lowest the priority. I think that makes sense. That you can actually probably do views, and you could guide help there as well on that one. Actions, auto. So this is our stop, which wants to be before our start. So let's take that there. So let's now put some text in there. OPTZ start, stop, sorry. OPTZ start. And then we've got a spare in 16, which I don't think we're going to be using, so let me take that slot out. In 16. Now the problem now with that, with you looking at that, you don't know what's in values. So let me go views, AX slot sheet, and let me do this as in 9. In 10. In 11. In 12. In 13. So now you can see what I've used. That is your optimization. done with high outside air set point, with frost protection for the space temperature, your lower and higher limit set, your space temperature, which you would input there, and you've got 4 or 5 sensors. You put it to an average block, or you could put it to a minimum block. It's entirely up to you how you want to play with that one. Your outside air doesn't really get used for this optimized start stop. I think I showed you that. Let me just, can't remember now whether I did or I didn't. Bring that back across. There'll be something here for outside air. No, outside air. Links to outside temperature and displays the value for information only. So it's only for information, but we're using it further on. Bring that back across now. We're using it further on for the outside air high to stop the system, but we can still override it with this switch here, because that's going into the in9 priority. And then from that output goes to your heating, so your boilers or whatever, or your VT. Now if it's just VT control, you would have a space temperature sensor, and you would have a control variable, set point. So space temperature sensor and a set point to switch on and off the pumps, and then you probably want to control a valve, and again it's going to be controlled on the space temperature, or sometimes it's controlled on, or mainly sorry, it's controlled on flow to the radiator system, or whatever system is there. I presume we could just put another block in there, duplicate, and we'll go for VT flow. Action set, let's say VT flows, I don't know, at 45 degrees. And we'll do a duplicate VT return. So say VT return is coming back, let's say 37 degrees. And then we need a VT set point. Set point, and say we're trying to maintain 42 degrees. And then we've got a VT valve, so let's do a new Boolean writable, not Boolean writable, valve 0 to 10. Fuse numeric writable VT valve control. Set that to 0. We'll do 0 to 100, 0 being 0 to 10. So let's put that as percentages. Click on that, percentage, put that to 0. Okay, save. Take out in 16, control on in 10. Now we need a loop, HVAC loop point, VT control. Let's expose some slots. Set point control variable, loop enabled, proportional integral, maximum is going to be 0 and 100 and 0. So loop enabled, so we can take that from there and put that into there, and then depending on whether we're using the VT flow or return as our control variable, our set point's definitely going to be into set point. We'll go in and put our prop to, for example, 2, and an integral to 1. We'll override true. So we've now overridden, so we're true. And our control variable, so if we're doing it on flow, that's now winding up for the VT valve. Or we can do it on return control variable, return temperature coming back. So you can either do it on flow or return. If you're not sure and you want the client to pick which one they want, what we could do is do another Boolean writable, type in their VT CV for control variable, actions set to false, pin slots take out 10, take out 16, views AX slot sheet, get rid of all the emergency overrides, config flags to hidden, so they've only got the set option on the graphic, and we can set that to VT flow, and we can set that to VT return, and then we can use a numeric switch, a Boolean switch, sorry, a numeric switch, so that's VT flow in there, which is false. So we take our VT flow and we put it into false. We take our VT return and we put it into true. We'll just move them across a little bit so it looks a bit neater. And then we can take our control variable, delete that, and we can use that as our control variable. So at the moment they are using VT flow. And then when we change that on the graphic, we ask it to use VT return. Now we're using VT return. So you've left the control now to the client to choose whether he wants to, or he or she wants to use VT return or VT flow. CV select. And there's you've still got your VT set point there. So they've got the option of using flow and return. They've got the option of adjusting the set point. I think what we would need to do with that is give them some limits. So you probably don't want to go above 50, and you don't want to go below 20. Well, I'll tell you what, let's just put that to 80. So we give them some limits to work with, depending on what system the VT is actually, the variable temperature is actually running to. But so we've given limits there, so when they actually come to do the set point and they come to set it, they've got a limit between 18 and 50. They can't go above 50 and they can't go below 18. 18 is really low. I don't think you wouldn't have 18 personally. So let's just change that. I still think that's low, but we'll leave it at 22. So that's their limits now. 22 to 50. I think that is it. That's your VT valve. To put your VT pumps on, if you've got a VT pumps, you really want your pumps running over time. That valve would normally be a 3-port valve. So in the 0 position it's flowing back. 3-port. And your pumps would just be on with your main optimized heating. Your pumps will come on with that output there, as what I'm doing with the loop enabled. And then you can do your pump changeovers, you can do your flow switch, but that's another. And there's previous videos showing you how to do that. Yeah, that is about it, I believe. I can't think of anything else that I could add in there at this time. So I'm going to leave it at that. If you've liked watching the video, please subscribe. If you learnt something, please subscribe. And by all means, place any comments and I will try to answer them or do videos for you. Thank you for watching.